good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have, as always, a great webinar on tap today with some really interesting information. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it on demand following the webinar today. We will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll get to as many as we can near the end of today's presentation. And we are also doing a drawing for 5 $50 Amazon gift cards. So stick around to the end of today's presentation. Hopefully we'll draw your name and you'll be a winner. Okay, with that, we'll go ahead and kick off today's webinar, which is From Zero to Hero, Continuous Container Security in 4 Simple Steps. Our speaker today is Shiri Ivtsan, who is Product Manager at WhiteSource. Hi, Shiri, how are you? Thanks for joining me.
Great, how are you?
Good, 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 thanks. I am going to actually let you get right into your presentation. I'm going to put myself on mute and let you get to it.
Perfect, so thanks a lot for the intro. Let's get started. So container security is a hot topic these days, and I'll try to keep this presentation as practical as I can to really give you practical tools that you can use in your day-to-day life as a DevOps to actually make the container more secure. But before we really understand the security aspects of containers, it's important to understand a little bit about what are containers and what differentiates them from virtual machines, which are, the traditional application types. So for that, we'll need to go a little bit into the history of applications. Before about almost 20 years ago, we had big servers, we had slow changing code and versions, and we had monolithic applications as opposed to today's microservices. And the change that actually came within the last years has came because of a business reason. We need to deliver software a lot faster these days because we need to beat our competitors. So that's why the idea of the technical idea of microservices actually came by, because of the business need. So again, the idea is to have small pieces of code which are loosely coupled from each other, to have these small microservices, and to have also smaller servers. So instead of having big servers, we sometimes have clusters of smaller servers, or even sometimes we don't have servers at all. We might be using serverless, for example. So this is the idea, and this is the little bit of the history. Now, as we go along and we understand the main concepts of containers, it will be a lot easier to understand how we need to secure them, because if you actually understand the idea and the main concept of a container, you'll understand how it is different from traditional virtual machines and how to better secure it. So let's go over some main concepts of containers. The first one is an image. The image is the basis of the Docker containers. And we're talking about containers in general, but of course the famous one and the most adopted one today is Docker. The idea is actually the same for all types of containers. So an image is actually the content at rest. This means that it's the set of commands that contribute to the container. An image is static. It's a file, so let's say the Docker file before we actually pack it into an image. If we want to actually run the container, to run the process, we need to perform the command of docker run. And this will actually build the container. So this is actually the image while it's running. This is the standard unit of the application service. And this is the most important thing probably. Next one is the engine. So the engine is the software behind the scenes that executes the container. Okay, so the idea is that behind the scenes, we do need hardware, right? We do need the networking, we do need the storage volumes and everything. So it's really important to understand that we have a lot of main things like these, even if we don't see them within the container. These can be clustered together. We need to make sure that on each container that we run, we actually have the container engine behind the scenes. Then we have the registry. So the registry is where we usually keep the images. It's important to mention that your container orchestrator, so for example, Kubernetes, ECS, Rancher, Docker Swarm, or any other container orchestrator will actually pull the images and will actually run them from within the registry. And it's also important to mention that we distinguish between two types of registries. So the first one is a private registry where only you or your organization actually have the credentials or the secrets to access to. The second one, of course, is a public registry where, so for example, Docker Hub, where you can take different images that other people have built. Of course, in terms of security, these two types are completely different, and we'll discuss that more further in the next slides. The last thing is the control plane. So the control plane is actually the management plane for the container. So for example, you can set specific settings and parameters like permissions for specific people, and this is actually the management part of the containers. Now, the container lifecycle is quite easy. I mean, you have a Docker file, which is again the commands that actually execute the container. Once you build it, it becomes an image. You save the image in a container registry, and then you can actually run that. You can either run it in your local server, or if you run multiple containers, it makes more sense to actually run them within a container orchestrator. So a container orchestrator will eventually help you to manage, to scale up. It will help with the networking, with the load balancing, and these type of things. Now, are containers more secure than virtual machines? So this is a question we get a lot, and there is sort of a rumor or a myth that containers are more secure than virtual machines. Of course, it depends. I mean, you can have the most secure virtual machine because you had all the security practices and the best practices of how to build a secure virtual machine. And on the other hand, you can have a very unsecure container if you don't follow the best practices. So in my opinion, it's all in terms of the best practices and the processes that make these tools secure. Eventually, these are just our tools. They need to help us in our day-to-day job, and it's our job to make sure that they serve us as we need, and security is part of that. Now, in terms of the security aspects and VM versus containers, so one important aspect is the attack surface. So attack surface is a basic term in terms of security in general, even physical security and not just software security. And attack surface is the sum of the different endpoints where someone who wants to hack the system or wants to exploit something in the system can actually access, enter, or extract data from my existing environment. We, as the security people, the DevOps people, someone who cares about our application, want to make sure that the attack surface is as small as we actually can, so that no one can actually somehow hack or enter into our system. So now it's important to also note some security aspects of VM versus containers. So the first thing is run as is, okay? So the analogy is basically I take an image from somewhere, someone else has already packed it and prepared it. I don't know exactly what there is there. So some people think it's like, just finding a hard drive somewhere and just sticking it into your computer because it's something that you eventually don't really know what's there. as an image, of course. You can always or sometimes look at the Docker file and understand the basics of that image. That's why it's quite dangerous to some extent. It's also invisible to some of the security tools because as containers are stateless and ephemeral, they come and go. So if I have monitoring tools, sometimes the container can actually escape from that monitoring tool. Another important thing to mention is that network is a lot different in containers than in regular virtual machines. So can be sometimes more dangerous with existing or traditional security tools. The next thing is that it's automated and it's also fast moving. So running a container, stopping a container, and also shipping a containers can be very automated quite easily with a container orchestrator. And it's also fast moving. So we might miss some bytes along the way. Sometimes we want to deliver our software faster, and there is a feeling like the security is already stopping us from actually going in the pace of the industry. So this is not true. You can do both security, but you can also have and deliver your application faster. And we'll discuss that in the best practices part. The next one is internal host networking. So I said something about it, but it's really important to understand that the internal networking in containers is a lot different than virtual machines. So of course, the concepts are the same. There is still load balancing between different containers, and there is still security and cryptography, but everything is to some extent different. So we have to make sure we understand everything, and we also get the right security practices to help us with that. The next thing that it's important to understand is the difference of a Docker image from a Docker container. So a Docker image is static, right? This is the immutable, this is the file that I actually have in terms of the snapshot of the container. A container is there while it's after we build the image. And images, as we mentioned, are stored in Docker registries. Now, image layers are a very important concept to understand when speaking about security. So usually what we have is we have the Linux kernel. This is the base of our container. Then we have the base image. So usually if you look at a Docker file, you'll see from Ubuntu, from Alpine. This is the Linux distribution, and we call it the base of an image. It's sort of a lightweight OS. You can think of it like that. And then we have the actual application layers. So as I write, every line that I actually write within the Docker file is a layer of the image. And layers can reference the parent image, or they can reference other images within the Docker image. And then on top of that, we have the container. It's important to mention that the container is writable. So I can execute different commands in the containers, and then I can actually commit the commands that I made and save them into an image. So some of the latest news before we go and understand the security practices, just so we understand how important this is to actually secure our containers. So a quite recent one and also quite famous one is the run-C vulnerability. So I have two items about it here. 11th of February 2019, this security was disclosed. And run-C is actually the runtime of Docker containers. It's also an inherent part of Kubernetes and other container orchestrators. So what eventually was found is that there is a privilege escalation problem with C. Now, what's important about this is not that there is some sort of vulnerability, open source vulnerability, of course. The thing is that usually when we see open source vulnerability, we'll see them in one language. So for example, a vulnerability of Java in our code might be affected. But when it's in run-C, which is a very basic part in containers, it actually makes us a lot more vulnerable because, runc is the base of each one of the Docker containers. So almost everything is vulnerable. The other one is another privilege escalation issue that was disclosed in December of 2018. And this is another very critical one that was disclosed. And I hope all of you have already patched the fixes. So in that term, if you're using a managed service, it might be easier because there is someone, so for example, if it's an existing cloud provider who is actually taking care of it. So the only thing that you have to do is make sure you have the latest version. If you manage the Kubernetes or the orchestrator or the Docker platform yourself, it might be a little more challenging. Now, what can we do? So I wrote here DevSecOps. It's not necessarily having a DevSecOps title in your organization, but it's more understanding the mindset of continuous security. So continuous security means to go from the very early stages of development all the way to the image registry, the build stage, the deployment part, and even after my application is in production, in understanding the different security consequences. So it's very important to have this mindset and understand that there are various things that we need to do in terms of container security, and it's not only when we build the image, it's not only when we deliver, it's across all the life cycle. So let's start with some questions, and it would be great if you answer them and, just to understand what's your status in terms of container security. And of course, that there is no right or wrong here, right? It's in terms of the maturity of your organization and also the processes that you have. But this can give you, to some extent, a feeling of how well do you do today. So the first one is, do you use a private registry? So we made this distinguish before. The idea is that private registry means that someone actually put all the images in one place. No one outside of your organization can access the images. So it's really good in terms of security, especially if you sign the images, and we'll speak about it in a second. On the other end, you can also have a public registry, but you can still take specific steps to make sure that all the images from the public registry are secure. The thing is to keep this in mind, to have the right mindset and understand whether what I'm doing is secure. Does it help the security, or am I just doing things without really thinking it through? When using a public registry, are the images signed? So we'll speak more deeply about signing the images, but I just want to give you sort of a feeling of what this is. So an image, as I said, is the content at rest. There's a very important feature of actually signing the images. So this is a feature that Docker has. You can sign your own images, and this means that you can very quickly understand, also in terms of the container orchestrator, did anyone change something in the image? So the idea is really to scan the image to understand whether it has any vulnerabilities. Once it doesn't have any vulnerabilities, it's really important to sign it. And from that moment on, you know that this image is currently secure. Now, of course, there are always new vulnerabilities disclosed. So it's important to have this process ongoing all the time. So the next question is, do you regularly scan your images? And we spoke about scanning images a little bit, but just to elaborate a little bit more. There are public databases of open source vulnerabilities. Like, for example, when this runc vulnerability was disclosed, it was automatically added to the NVD, which is the official database of security vulnerabilities. So this means that you can actually go and see if your image contains any known open source component that has a vulnerability. If it does, it's always recommended to perform the suggested fix. Usually it will be to upgrade to the latest version. But it might be also change some sort of configuration, not necessarily updating the version. If you scan the images, you can be sure that at that time there is no security vulnerability, which helps a lot. Another thing that is important to mention is hackers will usually try to exploit known security vulnerability, thinking that users probably didn't patch the latest fix. So we see hackers, I see it all the time. We see trying to exploit already known vulnerabilities, and that there are a lot of users who don't upgrade to the latest version, and this is why they can actually do them. So this is actually the next question. How quickly are images rebuilt with security fixes? The pace here is super important. At the moment that the security vulnerability is disclosed, there are online, you can find it for Runc, for example. There is a code that with the exploit itself. This means that hackers can actually take that and hack into different clusters. They can try, maybe they will succeed. So it's really important to have processes of images that can be rebuilt with security fixes. So these are just some questions. Now for the steps. So there are certain steps that you need to take in order to actually make sure that you are secure. And the first one is CI and CD gates. So CI/CD, continuous integration, and continuous deployment are processes that are part of probably each DevOps person's day-to-day life. The idea is, as we have our nightly build, for example, or our weekly build, and in this weekly build we have functional tests, right? And if some specific functional automated test doesn't work or fails, we will automatically fail a build and let our developers know that something is not working right. This is the exact same idea with security. So if there is something wrong in terms of security, we need to automatically fail the build. We need to integrate security testing into our CI/CD process. So as you build nightly, as you build weekly, you have to make sure that you also scan the code for open source vulnerabilities and fail the code if something goes wrong. So this is the idea basically of shifting security left, and starting to test really from the basic steps. So it doesn't mean that we automatically don't release the version. We might analyze the security vulnerability and understand that it's okay, and it's a minor security vulnerability, or my code doesn't even point to that specific reference, so it's okay. But it's really important to make sure that you know what are your security vulnerability, and decide to actually take a risk. That's okay. The next one is to use automated policy to actually fail the builds with issues. So as I mentioned, there might be security issues along the way. You want to make sure that you have some automated processes that will fail a build if something goes wrong in terms of security, just as we do with functional tests. The next one is, of course, to scan across the lifecycle. So it's not enough to only scan at one point and that's it. As I mentioned, the idea is to have a continuous security process. So from the very early stages of development, as developers actually commit the code and build integration versions in Jenkins, in Travis CI, in Circle CI, or in any CI/CD platform, we want to make sure these are tested frequently for security vulnerabilities. The next one is the container registry. So in terms of the container registry, as we said, this is where we keep our images. We want to make sure that this thing is completely secure. Of course, we would prefer always to have a private image registry. So some place where only you and your team actually have the secret and you make sure that each image that actually enters there is completely secure and signed. The next step is actually the deployment, and we will discuss it in a second. So the second step is trusted sources. And this is very important. So we already said it, but it's important to repeat it. Use private image registries. Sign your images if you get them from public registries. So it's okay. There might be sometimes images from Docker Hub that I need to get. Okay. But the idea is to scan them for security vulnerabilities and only then put them in my private registry. If I know that everything in my private registry is protected, it makes the whole process a lot more secure, of course. The next step is don't use defaults. And this is a very important step. It's relevant mostly to the container orchestrator part. So whether you're using Kubernetes or ECS or Rancher or Docker Swarm or any other solution, basically, there are some defaults. And sometimes these defaults are not very secure. So this is an example from Kubernetes, which probably most users are using today. So you need to enable role-based access control, which is RBAC, in your container orchestrator. So we know that for previous versions of Kubernetes, for example, RBAC was not enabled by default. When the large cloud providers actually came in and started having managed solution, they made it as a default, and now in the latest version, it's default for Kubernetes unmanaged as well. But it's really important if you're using a previous version of Kubernetes or basically any other container orchestrator, have role-based access control. This means that only privileged and specific user can actually access different roles within the containers. So this is very important. The next one is use namespaces or some sort of security boundaries. So this means that also in terms of network isolation, namespaces are isolated from each other at the network level. In terms of RBAC, also in the user's level. So for example, a container from a specific namespace sometimes cannot access a container from other namespace. So it's very important to have specific security boundaries. The next one is manage deployments. So this is the last step actually, and I think it's the most important or probably one of the important ones. So manage deployments actually means that also in production, I make sure to have the security processes as they should be. So this means that I prevent deployment of images with no vulnerabilities. So even if I did everything in the process right, and I scanned in the build step, and I scanned in the image registry, we might have some time between the images stored in the image registry until it's actually deployed into production. And during that time, new security vulnerabilities might be disclosed. So it's really important to have a gate that prevents deployment of images with known vulnerabilities. And in Kubernetes, for example, they have admission controllers, which can actually do this quite automatically. There are very good tools to actually do it automatically. So it's really important to take advantage of that and actually use it. And the next point is actually to prevent deployment of containers that require root. I would also say don't even sign these images if anything needs root access, as you wouldn't run in a virtual machine a process as root. You don't want to run any container as root. So it's the same concept altogether. The next one is, as we go through the deployment process, we actually perform apply -f to our Kubernetes cluster or to our Docker Swarm cluster. We want to validate that all the images that are deployed to my production clusters or even the development cluster actually have signatures, because I already signed them before, but it will be useless to actually sign them if I don't do anything with it in the deployment stage. So this is probably the most critical one. And another step, another critical one is actually after everything is deployed, you still have to worry about security. You still have to get updates for newer versions, both for the Docker engine, for the Kubernetes, and also for the application level. This is very important as well. And of course, monitor for new vulnerabilities. If you hear that there is a new vulnerability, of course, find a patch, but also have automated processes in your clusters that will monitor and detect new vulnerabilities. It's very important. And one of the challenges here is to actually understand which specific resource in my cluster is vulnerable right now. And there are some tools who can help with that, of course. So with that, we went over the 4 main steps of securing the containers. Right after we understood why do we need to treat containers differently in terms of security. So now I would like to open it for the Q&A session. So if you have any questions, anything that you want to ask, feel free to do it now.
Great, great. So we've gotten some really good questions in so far, but there is plenty of time to submit a question. If you do have one for Shiri, please just use your GoToWebinar control panel and submit it. Let's go ahead and jump right on in because these are some really good questions. First one, which orchestrators are recommended in the secure way to manage containers?
So as I mentioned, I usually distinguish between managed orchestrators and non-managed orchestrators. So Kubernetes by itself is just a tool, right? It can help us a lot, but it eventually is just a tool. It's up to you what you do in terms of the security aspects. So Kubernetes comes with some good defaults and some bad defaults. What I would usually recommend is if you don't want to take care deeply and understand the security aspects, use a managed solution by a cloud provider. This way, the cloud provider or the managed resource will actually take care of the most of the security aspects. Of course, you still have to worry about security in the application level, but at least the container level, you'll be covered. So I guess this is my recommendation. Of course, unmanaged clusters are great, but you just have to know what you do. So these are good too. Just in terms of the security, you have to understand deeply the consequences of everything.
All right, great. Next question. Let's see. Do you recommend running security scans or simply patching and rebuilding images with security fixes?
So it really depends. I mean, I definitely recommend to have security scans, and there are automated tools. I know that WhiteSource does this, but also other tools that actually open pull requests in an automatic way if there are fixes with newer versions or with more secure version. I wouldn't recommend to automatically patch them unless if you have very deep testing for your automation part for your application. So it can be quite dangerous to actually automatically patch any fix that comes out, as you wouldn't automatically upgrade always to the latest version. So it's important to always have. I would say the first thing to have is testing in place for the application layer, and then you can have automated pull requests and also automated fixes.
All right, great, great. Plenty of time for questions, guys. So just use your GoToWebinar control panel and get your questions in. Let's see. What is the role of CI/CD gates in security?
So as I mentioned, and I think we discussed it in some previous slides, but the idea is CI/CD, I mean the build stage, is super important. If you have automated tests during the build stage, this is like a classical place to put security tests as well. And then the gate would actually be fail the build if there is a security test that actually failed. So this is I think they have a great role in terms of security.
All right, great. Next question here. Can we use the security containers for embedded analytics?
I'm not sure what this what does it mean, but I guess securing containers can, you know, it's important for any type of container. It doesn't matter if you do embedded analytics or any other thing. Securing containers is also important no matter of what your application is working on. But if I didn't understand the question right, so just maybe type it again in a different format so I'll understand.
Okay, all right, great. Great. Yeah. Let's see. Next question. Oh, this is a good one. Whose job is it to secure the containers? Does there always need to be a DevSecOps position if you are working with containers in your organization?
Very good question. So no, definitely no. So DevSecOps, I think that other than a title, which is a very important one, it's a mindset. So whether if I'm the developer or the product manager or the QA person or the support person, security in containers is very important, and we all need to have that mindset because, as you know, applications, not only developers actually work on them, it's also the DevOps people, it's also the development managers. So it's really important that everyone will have that sense of urgency when it comes to container security and container security deployment in general. So that it doesn't necessarily have to be a DevSecOps. When speaking about containers, I think the DevSecOps is more relevant here, of course, because we need to ship our containers, we need to ship our software a lot faster. So maybe that's the reason that DevSecOps is more important here than in traditional applications, but definitely doesn't have to be one.
Okay. All right, excellent. Next question. Suppose we are using Docker on AWS. So will AWS take care of security, or do we need to add additional patches to make it secure?
So generally speaking, if you're using a managed solution and didn't just install Docker on a single EC2 machine, but you're using something like ECS, Fargate, EKS for Kubernetes, then the security of the container is already there. The only thing that you have to do is when deploying the actual applications or the Docker images, you also need to make sure that there are best practices in terms of security. Because at the end of the day, the application layer can do something completely different than the base image or the base Docker image. So even if you're working on a managed service, which is the recommended way in terms of security, it's also important to make sure that you're following the best practices of security.
All right, great. Plenty of time for questions, guys. So if you have one, please go ahead and send it on in. The next question, can you explain RBAC again?
Yes. So RBAC is role-based access. Role-based access in software in general basically means that I have all the permissions in the software or in the specific components, and then I can give specific permissions for users. Now, in Kubernetes or in containers in general, it's not only giving the permissions to real users, but also give permissions to applications. So for example, if we speak about Kubernetes, does a pod have the right or the permission to get other pods? Does the pod have to actually override things within the container? Does it have the right, I don't know, to execute something in root? Okay, so these are specific permissions that a container, a pod, a resource, or even a real user can have within containers. And it's important to make sure that RBAC, which is role-based access, which is a feature in Kubernetes, it can either be enabled or disabled. So in previous versions, it was disabled by default, and now we recommend to make sure it's enabled in your clusters.
Okay, great. Okay, next question. Can Rancher apply security patches to Docker images?
So I'm not sure specifically regarding Rancher. I know that Rancher is another option for a managed solution, of course. So you can either work on Rancher with Kubernetes or Rancher without Kubernetes. But there are, I'm sure, some security best practices in terms of Rancher. I'm not sure if it can automatically patch security, but I can definitely check this and get back to you offline.
All right, perfect, Lynn. Next question then. To what level do you see organizations transitioning from typical VMs to containers?
So what we usually see with our customers is that it's a process. So you don't just go and during one day or 1 week or even 1 month change from monolithic applications to microservices and Docker and containers. It takes time to shift there. But we definitely see that most of our customers, at least, are moving there. They're either working with containers or in development, or maybe even just in tests, but they're starting to explore. Of course, it's a matter of the maturity of the organizations. So some organizations that are newer to the industry already started, they're cloud native. They already started from the day that they were born with containers and microservices. So, but it's really a transition. It takes time.
All right, great. Okay, next question here is actually this is a really interesting question because it does, I think, illuminate a point of confusion among a lot of organizations here. If our cloud provider is taking care of security, then why would we be concerned about security since it's being managed by the cloud and we are paying for security as well?
That's a great question, actually. So to some extent, our managed services can take care of security. So for example, if we give the responsibility of actually launching the machine or, having the antivirus inside the machine to AWS, for example, they will take care of it. However, the application is still ours. It's still on us. So what we deploy on that specific machine that they gave us or on the cluster can either be secure or it can be less secure. So it's still on us to make sure that our applications at least are secure. If the cloud provider gives a managed solution, for example, of Kubernetes, so this means that the infrastructure and the level of Kubernetes is secure. However, we always have the freedom to do whatever we want in terms of the application. And that's why it's still important that we understand the terms of the security and we will follow the best practices for our applications at least.
All right, great. All right, let's see. Next question. Which type of corporate position titles do you see supporting Kubernetes, CI, CD, and containers?
So it really depends. It can be sometimes the DevOps, sometimes it DevSecOps, sometimes it's specific developers that get this role. Sometimes it really the CISO, the person who is responsible for security in Kubernetes. So I think that there are various titles who actually take care of security in container. It really depends on the organization and the processes there. So, but there are really various titles.
All right, excellent. Okay, great. Here's an interesting question. Do you believe containers are the next evolution of VMs?
So I basically believe that if we look like 5 or 10 years from now, there will definitely be VMs still. There will definitely be bare metal even. There'll definitely be containers, and I think also we're going to see a lot of serverless. Now, the question that nobody actually knows to answer is what will be the balance between them and how many will we see, like 99% of containers and then the other percent will be VMs, or will it be maybe more serverless? But I definitely think that we're going there because as I mentioned, it's a business need to go faster with applications, and eventually containers allow us to do that.
Okay. All right, next question here. Do you feel that vulnerability patching is reason enough to implement CI/CD processes and tool chains?
So I think security doesn't have to be the only, the only reason for implementing CI/CD. I think there are a lot of reasons, mainly, the business side and shipping applications and shipping your software faster, and also having automated tests. So there are various reasons to implement CI/CD processes in your company. I do think that security is definitely one of them. Yeah.
All right, great. And kind of a related question to that, if we include continuous security in CI/CD, does CS, continuous security, concentrate on code that is being promoted or the environment? For example, in containers terminology, does CI/CD gate for container security or Kubernetes security?
So it really depends. I believe that it should be across all the stages. So both when you pack the image, but also before that. So security can go from very early stages of development. So you can think about it like, how do I find the most secure image? You have sort of a research. You do it even before you start to code. You understand whether you should be using Alpine or you should be using, I don't know, CentOS. And you do that based on the functionality you need and based on the performance you need, but also based on the security. So it even go more left than this general, CI/CD part.
Excellent. Okay. All right, guys, there's still a couple minutes left. So if you have a question for Shiri, please go ahead and use your GoToWebinar control panel and get those questions in. The next question, do you advocate having a separate DevOps team in organizations, or should it be absorbed into the existing teams?
So again, it really depends upon the organization. I personally think that it's better that DevOps will be connected to the business teams. So it really depends how you work. But basically, I wouldn't isolate a DevOps team from the other developers team. I think they should work together, both in terms of security, but also in other aspects like testing and having, automated deployments and stuff like that. I think DevOps people need to understand the pains of the developers. That's why they're DevOps. So I think that not only in the terms of security, but also in other terms, it's really important to have the DevOps team within the developer department.
Okay, all right. We actually had one question asking actually, what is DevOps? I mean, the role of DevOps in their duties. So maybe it's worth breaking that down a little bit more as well.
Yeah, so DevOps, rather than being again a title or a role in the organization, DevOps is a mindset. And it means that we take automated action. So it comes, of course, from the terms of development and operations. And if we think again historically, operations was a completely different department, right? It took care of the servers, it had to connect cables, stuff like that. And now when we speak about organizations that deploy software like 5 times a day, 10 times a day, the operations is a lot more inherent to the development, and they need to work together. So the idea of DevSecOps is having people who are expert in development part, but also expert in operations and systems, and actually connecting them together to have faster delivery, to have better cooperation between the teams. And probably there are a lot more aspects to DevOps that we cannot cover in just a small question. But
right, yeah.
I hope that it's like the main part.
All right, great. So our next question, microservices are changing the way we develop, build, secure, and deploy software. Microservices are also creating new challenges around security, versioning, etc., tracking and versioning the use of services in large Kubernetes clusters. How do you see security in these large cluster environments versus smaller DevOps environments?
So I think it's kind of the same because eventually a cluster of servers or a cluster of nodes has very small resources within it. And these resources actually need to be secure. So it doesn't really matter if you handle 2 Docker images or if you handle thousands of pods in a Kubernetes cluster with hundreds of nodes. The security aspect and the security process that you have to take, of course, they're different in scale, but the term and the proper side of handling security is kind of the same, in my opinion, at least.
Okay, all right, great. Let's see, I think we've got time for 1 or 2 more questions here. What are going to be the primary skill sets, in your opinion, that folks will need in the DevOps field in the next 5 years? Not to throw you a curveball or anything.
Yeah, I know. So this is, I would say that in terms of both security, but also in terms of DevOps in general, we have to run fast. I mean, we have to deliver our software fast, but we also have not to forget the processes. So sometimes these processes actually slow us down, but it's important to have them in place. As a DevOps member, you're actually responsible for more people, for the developers, for the development team leaders to actually perform the processes as they should. So I think that the DevOps needs to be someone, of course, that has a very extensive technical knowledge that can learn very fast, but also a people's person that can affect some other people in their own environment. So these are, I think, the important aspects of being a DevOps in the next years, I guess.
Okay. All right, great. Let's see. So is there a way I can do something as part of the development process to make sure I have fewer vulnerabilities during the deployment stage? Is there something that I, as a developer, can do?
Yeah, so there are a lot of things that the developer themselves can do. So as I mentioned, from their very early stages, so as a developer, I have a task, and I need to build some functionality. So I can go ahead and check the open source components that actually help me to build it. And here again, we mentioned the research part. I think here the research is also critical. So for example, in the open source world, there are a lot of components and some of them actually do the same thing. So I need to make sure that this component is good also in terms of the functionality, but also in terms of the security aspect. So it's important, even before I start to code, I need to understand what is this component, how many defects does it have, how many open issues, how many security vulnerabilities, how often is it maintained. So this is, as a developers, I think these are questions that as a developer you can answer, and it will give you a sense of, am I doing it right or wrong, both in terms of security and also in terms of functionality.
All right, great. So I think we have time for one more question. How would you suggest to automate the enforcement part? Is there a way to automatically reject images with vulnerabilities?
Yes, so I mentioned admission controllers for Kubernetes, and there are a lot of other tools that can actually block or enforce images from being deployed to your production if they have security vulnerabilities. WhiteSource various solutions to this challenge or issue, but I know that, for example, in admission controller, you can actually set specific rules for an image before it's deployed to production. You can also have a specific webhook to sort of understand with a remote server if it's okay that this image will be deployed to production. And the last part that we also mentioned is signing the images. And that's how you can also verify and enforce the security aspect in production.
All right, great. Well, unfortunately, that is all the time that we have for the question and answer period. If we didn't get to your question, I am very sorry, but we will make sure that Shiri gets a copy of all of the questions, and I'm sure she or somebody else from her organization will be more than happy to follow up with you offline and get your question answered. Okay, so I promised at the top of the hour we would be doing a drawing for 5 $50 Amazon gift cards, so let's go ahead and do that real quick before we close things out. And our first winner for the gift card is Glenn Seiler, I think it is. Congratulations, Glenn. Our next winner is Sergey I'm going to mess this up and I apologize. It's Silnatiev, I think. Congratulations, Sergey. Our third winner is Kirill Bludalin. Congratulations, Kirill. And our fourth winner is Jaron Janke. Congratulations, Jaron. And our final winner is, oh, here's an easy one, Bruce Yarborough. Congratulations, guys. I really, I wish you the best of luck with those $50 Amazon gift cards. I wish I was having one, but I'm not eligible. So you guys go forth and shop on my behalf. So, Shiri, thank you very much for giving such a great presentation. It was really, really fascinating, and there are a lot of questions that you're going to have to answer offline for folks, I think, judging from the number of questions we did get in. So want to remind the audience that today's event has been recorded. So if you missed any or all of the event, you will be able to listen to it on demand. Or if you just want to listen to it again, you will be receiving an email later on that includes a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go check there. Just go to devops.com/webinars, and it should be right there waiting for you in the on-demand section. And while you're there, please take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be one or two that pique your interest. And I do want to thank everybody for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.